don't see the screen. Okay, fine. Now, okay, now again, please read, huh? The learning
Okay.
outcomes.
Candidates should be able to, number A, define the temperature in terms of place and area, and the calculations using the equation pressure for the force divided by area. B, explain how pressure varies with force and area in the context of everyday examples. C, describe how the height of a liquid column may be used to measure the atmospheric pressure. D, explain quantitatively how the pressure behind a liquid surface changes with depth and density of the liquid in appropriate examples. E, recall and use the equation hydrostatic pressure P equal to, uh, what is this? Is it rho?
Rho GH.
Oh, rho G H. I think I learned this before somewhere.
Hmm.
F, describe the use of a manometer in the measurement of pressure difference. G, describe and explain the transmission of pressure in hydraulic systems, with particular reference to hydraulic press and hydraulic brakes in vehicles. H, describe how a change in volume of a fixed mass of gas at constant temperature is caused by a change in pressure applied to the gas. I, recall and use P1 V1 equal to P2 V2.
Yes, so here we get formula of pressure, you know that one. P equals F by A, right?
Yes.
You know it before. Now
I have
we
only
have,
basic knowledge and nothing else.
yeah, then we
Even
will
less than
try.
basic knowledge.
Yeah, you also have this idea like everyday example. If you apply this formula according to this idea, we have lots of instruments we are using or lots of activities we are getting in our life regarding this formula. Like if you are using a sharp knife, then it will work more, right? To cut the
Yeah, it
vegetables.
has less surface area.
And we are applying the force on the board pins. That time we are applying force and greater force is created in the sharp edge. That's why it's going inside, right?
Yeah.
Isn't it?
Yes.
Then this is about the sharp things. We are getting the benefits. Then if you are thinking about the wider surface area, the skier is skiing on the soft snow. That time the ski's surface area is bigger, right? If the skier is not using the skis, only he wants to go by walking only. Huh? That time in the soft snow, he will go sink, right?
Yeah.
But if the skier is using the ski, that time it's because of the surface area greater, so the pressure becomes less on the soft snow.
Yes.
He can move over the soft snow easily, right? And we
Yes.
have also some other examples like caterpillars. Huh? Uh, you know,
Um.
these are
Yeah.
huge,
Caterpillar.
yeah, heavy things. So if it is going through the any road or any place, then they are because of this heavy their heavy mass, then they should go down, right? And they
Yeah.
can do lots of damages on the ground. But their surface area is bigger, that's why they can move easily, right? Without making any
Yes.
damage. Or in the soft mud also they can go, right?
Yeah.
Yeah, then we have big trucks and lorries, right? They are carrying lots of loads. So those trucks and lorries, if they don't have, large number of uh, tires, wide tires, then they might sink in the ground and damage the
Yes.
roads, right?
Yeah.
And this is lessened by using more number of wheels and bigger surface area tires, right? Wide tire,
Yes.
so that the surface area increases, pressure becomes less on the ground. They can go smoothly. So these are the some examples. In this way, we can give lots of examples, like in the sand, in the desert, the camels.
The feet
Their
have
feet
large
are not
surface
like
area.
the cow's feet, right? They have
Yeah.
wide surface area under under the feet, right? The camels,
Yes.
so that they can easily walk over the sand. Okay, so
Yes.
this way there are lots of examples we have in our life. We have lots of experiences about the formula. This formula, pressure equals force by area. That one we are having in learning outcomes B. Now the thing we are going to discuss, that one is completely new for you. That's related to the liquid pressure. Okay, especially it's related to liquid pressure and air pressure. That is liquid column. Height of the liquid column. If the height of the liquid column is more, then the pressure is
More
more.
pressure.
Okay. Okay. So we have one formula you see here. uh, these these three learning outcomes C, D, E are related to the same thing. That is related to this formula. E equals rho GH. Like if you are thinking of water, okay, like you have one lake beside your house, and the water in that lake, if you think of, in some places the depth of the water is more, and some places the depth of the water is less, right? Isn't it?
Yes, sir.
Under the water, everywhere is not plain, right? There are some places there are more deeper, and some places there are less deeper, isn't it? Hello. Yeah. Adita. Adita.
Hello.
Yeah, Adita, are you listening?
Yeah.
Are you listening, Adita, now?
Yes. Yeah.
Okay, so what I was saying, beside your house, for example, there is a lake, and in that lake, you have water, right? Lots of water, plenty of water, and under the water, everywhere, the height of the liquid level is not same, right? Hello, Adita, are you listening?
Yeah. I think there's some problem with my mic because
Yeah.
I was talking all this time.
Hmm.
Um,
So
yeah.
if you are not listening, tell me, huh? So if you think of the water, then everywhere in the lake, the density of water is same, isn't it? Hello?
Yes.
Yeah, density of the water is everywhere same, and gravitational field strength in the same place is same. So your these two quantities, density and the gravitational field strength, these are same, constant in that place.
Okay.
Yeah. So we can write that P is directly proportional to H. That means if your height is more, uh, if your height is more than your, hello,
Hello.
if your height is more, then the pressure will be more, isn't it?
Yeah. So like it's
Yeah.
proportional to pressure.
Yeah. In the same place, if you are using the same density liquid, that time it happens, right?
Yeah.
So we are having here this formula new for you. And C, D, E are the similar thing related to this formula. Huh? That's
Which
that's
formula is new?
yeah, this formula.
I think I learned this
You
in
you
class
did it.
7.
You did also in class 7.
Yeah, this formula.
Oh, you
You
did.
taught this. There was the teacher actually, I don't know. I think the teacher was gone or was on leave, and then you did the proxy and you taught this one.
Okay, okay. So uh, we we will then again discuss this one. No problem. Then we have manometer. Manometer is a device which or instrument which one is measuring the uh, air pressure. Okay, air pressure like gas pressure. Like we have, in our house we have the uh, gas, right? Gas supply. How much pressure the gas has, we can find using the manometer. Okay. Also in the
Okay,
CNG filling station, they are also getting the pressure, huh? Using the manometer. Okay. Then
okay.
we have hydraulic systems. Do you have idea before this one manometer?
Hydraulic manometer.
Uh,
I think I learned it in geography for some reason.
okay.
I have some like little bit idea about how this works. The difference in height of the columns is like the
Okay.
pressure or
Okay.
something.
Yes. Then you have idea about this hydraulic brakes, hydraulic pressure.
Yeah, a little bit.
Yeah, little bit. This hydraulic brake also, hydraulic system also works using this formula. Pressure equals force by area. We are getting the benefits using this formula. Then here we have describe how a change in volume of a fixed mass is about the gas. This one is H and I. These
What did
two
you
are
do?
yeah. These two are related to the gas pressure. And gas pressure, how it is related to volume. That one we are going to discuss at constant temperature. Fixed mass and constant temperature, we have volume and pressure inversely proportional. Okay, that is
Yeah,
Boyle's law.
yeah.
So now we have here all this. We have this discussion. Yeah. So let's start the topic from the beginning. So in your copy, you write it, the topic name, topic 7, pressure, and write today's date. Now you read it, pressure. Oh, hello, Aditya.
I actually got disconnected, but I don't. Yeah, there's no electricity.
Okay, okay. So actually, I was saying that we are going through this whole notes to show you that we have lots of discussions here, huh? For everything according to the learning outcomes. We arrange the notes, huh?
Okay.
Orderly, huh? Like just
Okay.
look here, we have this P1 V1 equals P2 V2 at the last, and at the beginning we have that formula, huh? P equals F by A.
Okay.
So we want you to write the topic name, topic 7 pressure on your copy. Physics copy, write it, topic 7 pressure.
Okay.
Then you read it, huh? Read this part, pressure.
You can push a drawing pin into a piece of wood, but you cannot push your finger into the wood even if you exert a larger force. The difference in each case is a difference area in contact. The pin has a much smaller area in contact than the finger, hence exerts a much higher pressure that makes the substance yield to the force. Pressure P is defined as a perpendicular force F acting on unit area of a surface, or the force per unit area A. SI unit of pressure is the Pascal or Newton per meter square. It's a scalar quantity. Example: find the pressure exerted on a person by a few plastic blocks of total mass 42 kilograms, the bottom of which in contact with the person has an area of 840 centimeter per square. What? So what is this?
Yeah, which one? State.
840.
Centimeter
This
per,
one.
yeah, it's area is centimeter square, centimeter square.
Oh,
Mistakenly, it is written centimeter per meter
no
square. It's
problem.
centimeter square.
Okay.
So you write this heading pressure, then write this definition, then formula.
Okay.
SI unit, SI unit of pressure. You write. Then you calculate it. Huh?
Okay.
Well, you got the answer.
1 minute. Wait. The area is centimeter square or meter square?
It's centimeter square.
Okay. So can you hear me?
Yes, yes. Say again what you said.
Yeah, I was talking until I realized that I got disconnected. It comes 5,000 pascals.
What's your answer?
5,000.
Yeah,
5,000.
5,000.
Hello. Yeah.
5,000 you got.
Yeah.
So you are going to find the pressure.
E- the pressure is 5,000. Right.
Yeah, how you got pressure 5,000?
Force by area
So what is your force?
420
420.
newtons. Yeah.
Then your area you converted.
Yeah, to meter square by dividing by 10,000.
Oh, then you got the answer in Pascal,
Yeah.
Newton per meter square.
Yes.
So you got then 5,000,
Yes.
5,000 Pascal. Then
Yes.
if you now increase the, they are saying, state what will happen to the pressure if the area is now decreased to very small value.
Then the pressure will increase.
Pressure
It's
will
inversely
increase.
proportional to area. It
Yeah,
will increase.
yeah, it will be huge, right? Pressure.
Yeah.
So you got this idea. Now, yeah, you write daily life examples.
Okay.
Daily life examples. That is, first one you write knife.
Okay.
Knife, knife you give hyphen. It has smaller surface area. So by applying a small force, we have greater pressure,
Okay.
which helps us to cut vegetables and other things easily. Second one gave uh, wide wide tires of trucks, wide and large number of tires of trucks, lorries.
Okay.
Then you give hyphen. Then you write trucks, lorries, wider surface area in the wheel, uh, which decreases the pressure. so that they can move easily on the road without making any damage.
Okay.
So just two examples I gave you. The other things we discussed, right? You can remember. Now,
Yes.
this one we have the second thing we are going to discuss here hydrostatic pressure. We have pressure due to the liquid here. So all these discussions are
Okay.
here related to this. And here we have the derivation of the formula. Hmm. Then read
Okay.
from here, please. A simple derivation of the formula.
Simple derivation.
Uh, read.
Simple derivation of the formula for hydrostatic pressure. P equal
Hmm.
to rho times G times H. Consider a column of water occupying total volume V and a base surface of area A. The weight of all the water is W equal to mg. Recall that the mass of the water is just the density of the water into volume of water m equal to rho times V, the mass. Okay.
Hmm.
Hence
Hmm.
W equals to P times V times rho times V times G. So
Hmm.
we note that the volume is a product of surface area and height equal to AH. So W equal to rho AHG. We recall that formula for pressure P equals F by A. Substitute in W into F to give P is equal to rho AHG divided by A. Therefore, rho equal to P equal to rho HG.
Okay. So look here. I don't know you got it before or not this derivation. So here we have the proof that from where we are getting the formulas, right?
Yes.
So we have some basic formulas. We know about the formula of density, formula of weight, and formula of volume. Using these three formulas, we are getting our other formula P equals F by A. So four formulas are given here, and these four formulas are
Okay.
used to get this relationship P equals H rho V. Okay, so uh,
Okay.
here you write the heading hydrostatic pressure, hydrostatic pressure, uh, hydrostatic pressure in bracket you write liquid pressure, hydrostatic or liquid pressure.
Okay.
So can you read this part now?
Liquids and gases are called fluids, as they can change their shapes easily. Fluid is a substance that can flow. In the figure above, we notice that the water from the right container is going further than the water from the left container. The only difference between the two containers is the height of the water column. Hence, we know that the amount of pressure inside a body of fluids increases with its depth or height of fluid column.
Hmm. So look here, we have this simple experiment is showing us how the pressure is working, right? Liquid pressure. We have here more height of the liquid. That's why from this part the water is flowing. It's going a bit far, right? Huh?
Yes.
And here we have
Yes.
less depth, so it's not that much going because the pressure is less here, right? So this simple
Yes.
experiment is making us understand all those ideas in our daily life. So now pressure due to a fluid column. You see, we have here different shapes of the container or the reservoir we have here. All of them they have the same depth.
Okay.
We all them have same depth, and that's why the pressure under them here for all of them are the same, right?
Yeah.
Clear? According to our that formula and ideas, we have BH rho here. So rho G constant, then pressure will depend on only the height. As the height for them
Yes.
same, so all of them at the bottom they will have the same pressure. Okay. Now
Okay.
here we have another example where we can understand it. Here we have P3 is the bottom part. Here pressure is most, then P2, then P1, then P0. Okay. Here we
Okay.
have sometimes we we have the container open. That time the total pressure at this point we should calculate not only the liquid pressure, also the atmospheric pressure. Okay,
Okay.
so if you
Okay.
want to calculate the uh, pressure at this point A, that time you have to calculate by adding the atmospheric pressure with the liquid pressure. So P naught is the atmospheric pressure plus rho gh is the liquid pressure. Okay, is it
Okay.
clear? Now you
Yeah.
draw this diagram. Hmm. Uh, Draw this diagram, then you write this formula and also write it where P naught is the atmospheric pressure.
I'm done.
So we are now uh, going to atmospheric pressure. Atmospheric pressure and
Okay.
the rest part we will discuss after the break. Okay.
Okay.
Then our class will start 5:40. Okay,
Okay.
half an hour break.
Okay, sir. Simple, sir.